muting. We're recording. Okay. And does someone mind grabbing this door? Anyone? Sorry, you gotta put your stuff down. It's very inconvenient. Thank you so much. Cool. Welcome back. I'm glad you came back. I'm glad we didn't scare you away. We're getting into some really cool stuff today. As you know, we're going super mega fast. So we're really gonna get into coding today, and some fundamentals. Yeah. So, okay, that's fun. Okay. So there's actually quite a few announcements. Just want to make some clarifications. There's been a couple of changes. Amazing. Can you take that to silence in the back? I don't mind. Thank you. Yeah. So some of you may have noticed the 1 to 3 lab is majorly crowded. If you can find another lab time that works for you, either the 9 to 11 or the 11 to 1, it would be amazing if you switch to that. It is more likely that you will get help there if we are able to redistribute a little bit. I know everybody wants the 1 to 3, everyone wants to sleep in or has other class, but if you can, that would be amazing. Also, if you have complex, I know some people are taking more than one class, if you can make part of lab, that is going to make a huge difference for your finishing labs and getting through them and getting the points. Yes, they are not worth a ton of your grade, but that is where you're going to get the most hands-on experience in this class. And that is then in turn going to make sure that you finish homeworks in time, that you're able to do well on exams, and that your overall understanding is improving in this class. So please, please, please make sure you're doing the labs. Coming to some lab is better than nothing at all. And if you're doing that, please just let your lab TA know. They'll be fine with it. We know that there's a lot going on in summer. So just communicate. There's a theme here. Homework 0 is due tomorrow night. It's just to introduce yourself, and the syllabus quiz should be super easy. Take you maybe 5-10 minutes. Tell us about yourself. Make sure or confirm to us that you've read the syllabus. We also have a homework party tomorrow because homework 1, the actual content homework, is coming out today. So please attend that. It's going to be online on OYA. OYA should be pretty intuitive. If anybody wants near the end of lecture, if they want to come up here, there isn't anyone immediately after us as far as we can tell. We can do a quick OYA demo if you're worried about using that, but if you click the link on the website, it's probably going to be just fine. Yeah, so please come to that. There are TAs there. It is specifically designated for project work time. So if you want to get ahead, homework work time, sorry, homework. Yeah, so if you want to get a head start, please do come. As it's due, when is it due? We don't have a due date. It's due Monday, so there is not a lot of time. And that is going to be our one place where you can come get help on it, besides lab and office hours. Discussion starts today, which is super exciting. That is going to be where you're going to be working through problems, kind of in a more of a traditional classroom setting space, and where you're going to get more individual help. Lecture is really more for exposure and introduction to topics. Yeah, so discussion is going to be like right after this in this very building in 310, so to 310 and 320. I think Vedansh's got slightly more packed than Silas's. They're at the same time. They're going to be the same worksheet. So when you get there, if you want to redistribute yourself so that neither room is totally crowded, that would be amazing. And the 5 to 6 p.m. is still pretty empty. It's also pretty. Self-check for yesterday is due tonight. Again, that is on your grade scope, should be very easy points. We're all about grabbing points in this class because again, it is not curved, it is binned. Lecture 2 self-check, that is going to be about today's lecture, is going to be due tomorrow night, and it will go on like this for the rest of the 8 weeks. So make sure you do that. I think we're going to get to a point where we start having them come out during or before lecture so that we can actually, you can just fill it out during lecture and kind of make sure you're tuning in and able to answer those questions as they come to you during lecture. Again, I just want to clarify. So in this class, you should have lab 4 times a week. It's not like a choice. We have lab coming out Monday, Tuesday, Wednesday, Thursday on a usual week. So you should be going to every day, Monday through Thursday. It should look like this. I go to lecture, or I go to lab, I go to lecture 3 to 4, and then I go to discussion either 4 to 5 or 5 to 6. So every day will look like that with the exception of Tuesdays and Thursdays when we don't have discussion. Any questions about that? I just want to make sure that's clear because sometimes it's like, oh, maybe I can go to 2 of these labs. Please no, go to all 4. But is that good with everybody? Can you get thumbs up? Very cool, amazing. Yeah, I think that's about it. Yeah, that was that. We're gonna get into some stuff. So pull out notes or whatever. We're gonna get started.
Hey, hi everyone. We're going to get started with talking about procedures and the abstraction barriers. So we're going to talk a little bit more about the fundamentals of coding, and then Maddie's going to go over how to actually do things in Snap a bit. But yeah, so the term procedures. So we've seen that Snap allows us to create our own blocks, and hopefully you saw that in lab this morning as well. So something similar to creating your own blocks is something that exists in almost all other programming languages, or at least the ones that are most commonly used. However, the word block is a Snap specific term. Usually in other places it's called like a procedure or just like a function. But we just call them blocks in Snap since Snap is allowing us to like actually drag things out and it just looks like a block. So what a procedure is it's just a sequence of instructions that are packaged into one single unit. And so as an example, we have this draw square block, which I think we also had yesterday. And it's basically just drawing a square at a specific location given an X and Y coordinate. So that's just what a procedure is. And then now we're going to talk a bit about abstraction barriers. And another name for abstraction barriers are interfaces. They're kind of the same thing. But if you remember what abstraction is, we talked about it yesterday. It involves detail removal and generalization. And it's basically just a way for us to abstract away the details of how something works and just kind of allow us to assume that we can use it correctly and that it'll function the way that it's supposed to. So where the thing that separates how something works from what we just expect it to do is called an abstraction barrier. So usually, and this is a pretty common topic in coding in general, and your future CS classes you'll see as well, is that we talk about this thing called the abstraction barrier. And as a user, you never want your user to have to know anything that's going on below the abstraction barrier. So what does that mean? What that means is above the abstraction barrier, which is where a user is, for example, with this draw square block, all the user knows is that this block is going to draw a square at the coordinates X and Y. They don't know anything else about the block. They don't know how it's going to draw the block. They don't know any details about whether it's rotating or if it's just like picking up the pen and moving or something like that. But it just assumes that the behavior is correct. It doesn't care how the square is drawn, just that it's drawn at this location. So that's all the user knows, and they're above the abstraction barrier. Then below the abstraction barrier, this is where the creator is, the person who wrote the code for this block, the person who's doing the actual coding. So that's you in this case. We're coding up this draw square block, and the creator needs to ensure that the block behaves as expected. So below the abstraction barrier, we don't care about what the block is being used for. We don't care about why we need to draw a square. We don't care if we need to draw like 10 squares. All we need to do is make sure that this block can only draw one square, and it's fine if the user is using it to draw squares like at many different locations. We just need to know that whatever X and Y coordinate is given, we want to be able to draw that square. So the abstraction barrier in this case is our block itself, because above the abstraction barrier is the user who just knows that the block works the way that it's intended to, and below the abstraction barrier is the coder who just knows that they need to code up this block to draw a square at this location. Does that make sense? Okay, cool. Yeah, so that's like kind of a fundamental idea. And so it's just some general examples of abstraction barriers. Like I mentioned, blocks in Snap. Another example that we also kind of talked about yesterday was like gas pedals and brake pedals in car. So similar to like the block and us just not caring about how the block works, just assuming that it works in a car, you don't really know like how the brake pedal is working. So if you're above the abstraction barrier, you don't really know that like what wires are connected to what and how is pressing the brake making it to stop. You just assume that it works correctly. So it's the job of the creator of the brake pedal to ensure that the brake pedal works correctly. And they don't necessarily know what car it's being put into maybe, or if it's being put into a car or like a bus or something like that. They just know that they're creating a brake pedal, and it doesn't matter how it's going to be used, just that they need to make something that when it's pressed is going to stop the vehicle that it's connected to. So that's kind of the distinction there. Another example is hiring contractors to complete a construction project. So the reason that this is an example of abstraction is because when we hire contractors, we're assuming that they're going to just take care of completing the construction project. But something to note is abstraction just kind of follows further and further down. So the contracting company that we hire, so we just assume that they're going to complete the project. We don't worry about how they're completing the project. But what they're going to do is they actually hire a master electrician who deals with all the electricity for our project. And they hire an apprentice who deals with all of those details. So everyone is kind of using abstraction as you go further down. But us at the top, when we hire the contractors, we don't even know that they're hiring all these other people. We just assume that it works. That's the idea. Similarly, with our core staff for CS10, like us as instructors, we just hire TAs, train them, and then we assume that they're going to teach you correctly and run your labs and discussions. So yeah, hopefully those examples make sense. Any questions about abstraction? Okay, cool. So we're going to move on to back to programming. So why we want to use procedures. So if you recall a couple slides ago, a procedure is just a sequence of instructions that are packaged into a single unit, which in this case, they're packaged into a block. So procedures act as abstraction barriers. So they allow us to generalize our code to different situations, and they serve as the building blocks of our program. And that's, again, like kind of why they're called blocks, because once we create all these blocks that do different things and help us accomplish our tasks, we put them together to create our main program to run. And you'll see that a lot in your labs and in homework 1 as well. And these can be composed together to make larger things. And the main thing here is that building these blocks allows us to break our big problems down into much smaller ones. And it's called functional decomposition. You don't really need to know that term, but it's basically just the idea that we're breaking down our big problem into smaller problems. So it's kind of like, if you think about it, it's like if our main problem is like we want to draw a house or something, but we're like, oh, it would be really easy to draw a house if we just had a block that drew a square and we had a block that drew a triangle or something like that. So those are kind of our smaller problems. If we can somehow make blocks for those, then we can put them together to solve our big problem of drawing the house. And you can always make that go further and further down. So that's why we want to use procedures. Now I'm going to talk a bit about functions. So functions are probably a term that you've maybe heard in math class before. So mathematically, a function you might have seen as like f of x equals something. So it's like a function of x. And in math class, we learned that functions take in inputs and they give back outputs. And so as an example, we have f of x equals x cubed. That is a function that maybe you've seen in math class before. And so if we have f of 3, that gives us 27. Because if we have 3 cubed, that gives us 27. And then as another example, f of -5 is going to give us -125. So I think the slide might be wrong, so I'll fix it in this, or yeah. But so basically we can imagine this as some sort of like machine. And whatever input is going in here, it doesn't really matter how the function is actually calculating the value of it being cubed, but it's just going to output the value. We assume that it's going to cube it. So I think this is supposed to say like a block. Can think of a block as a function machine or as a reporter as a function machine. So whatever we pass in, and we'll show you how to code something like this, we're going to assume that it's going to give us a function. But does this make sense, like mathematically, what functions are? Yes. Okay. Okay. So now, sorry, there's a lot of words on this slide, but now we're going to talk a little bit about like what a pure function is. And this distinction is a little weird, but we won't ask you like too tricky questions about it or anything. But so a function is, by definition, it's something that takes in 0 or more inputs, and it's going to return exactly 1 output. And the same inputs must always yield the exact same output. So that's a key thing in a function, is that the output from your function has to be a result of only something based on the input and nothing else. So if we have like a function that is squaring a number, like every time we pass in 2 into our squaring function, it always has to output 4. We never want it to output something else, right? And it's possible that you have like the same input, you have a different input that gives us the same output. For example, if we're squaring numbers, if we pass in 2 or -2, both of us will give us 4, and that's okay. But the main thing here is that the output should not change if the inputs don't change. And some other rules about functions are, these are like some newish terms maybe, and we'll talk about them, is that we don't want to have any state. So this is referring to any prior history. The result of the function should never depend on anything external. So anything external in your system, like for example, if you have say you're making a game and you have like a score function. So this isn't actually a pure function because the score is going to be dependent on the state of the game, right? It's going to be dependent on how many points you've earned so far. So for that reason, that wouldn't be an example of a pure function. So that's kind of what state is. And then mutation is kind of like similar because you might be like mutating a state, but we don't want to ever be changing anything in our function. And that doesn't mean that you can't change anything in your code ever, because obviously you will need to be changing variables and making changes to the state of your project in order for it to actually do anything. But if we're just talking about pure functions, these things should not ever be changing the variables. So for example, again, back to our square example, if we have a function that squares a number, we never want that function that's squaring the number to actually change the value of some variable that was passed in. We just want it to tell us the result of squaring it. We don't want it to actually change the value. So that's like an output versus changing it. And if we were going to change it, that would be a side effect. So a side effect is just something else happening that's outside of just giving us an output. And we'll give some examples of that. But those are like the three main things about the rules for a function. And then just a note is that the notation of function is a bit confusing, because in the real world, sometimes it's used to just refer to anything that has inputs and outputs, or any type of procedure that doesn't actually, even if it doesn't return a value, or it doesn't follow all of these rules. So if we're talking about something that explicitly follows these rules, especially on exams, we'll be sure to actually say like pure function. So it's very clear that we're talking about something that's like this, doesn't have side effects, doesn't do any mutation. So yeah, we will be using that term when ever asking you questions about that. Does anyone have questions about pure functions? Okay, so now let's just look through this example. So we have this count by block, and this, I don't think this is a block that actually exists in SNAP, but let's just say we made it. And so the first one we see here, we have count by 3, and we passed in 3 and it gave us 3, right? And then next we passed in 2 and this gave us 5, right? Does anyone have any ideas of what count by of 4 would give us? Any guesses? Yeah. No? Okay. Yeah. 4, I think. Oh, 9. Okay, yes, 9. Yeah. So yes, this would give us 9. And the reason for that is because we are first adding, so when we start off, so assume that these are running in order, right? So we start out with 3. We say count by 3, so we just assume by default it's just going to give us the value back. And then we do count by 2 on that. Now it became 5, and now it became 9 after we did count by 4, right? So basically it's just adding to itself. So the question, or does this make sense, like why this gave us 9? Okay, so the reason that we're doing this here, or sorry, so the question here is like whether this is a pure function or not, and it's actually not a pure function. And the reason, even though it takes in input values and it gives us output values, it doesn't always return the same value for the same argument, because it has side effects. And we'll talk about what that side effect is in a second. But so in this case, we didn't show an example of inputting the same number. But if we were to input 4 again here, we would get 13, right? Because it's just going to add to whatever the last value was. Does that make sense? Why count by 4 again would give us 13? Okay, feel free to stop me at any time if there's confusion. But yeah, that's the idea. So it doesn't always return the same value for the same argument, so it's not a pure function. And so the question is like, what exactly is the side effect of this count by block? Because yeah, so the side effect is that we have to keep track of something while we're going on, right? So here, like we just start out at 0 by default, but then when we're doing count by 2, since we already did count by 3, our block has to somewhere be keeping track of that the last value was 3 that we added, right? And then once we get here, somewhere in the block or something, it had to be stored that the last time when we reported something, it was 5, right? So that's kind of like, that is actually kind of a state, but keeping track of that state and updating that state is actually a side effect of the count by block. So the block has to keep track of whatever that current value is in some way in order to actually add the input to that and then report that back up. And it also has to update that value so that in the future, when this block is called, it's giving us the accurate result. So it's maintaining a state and it's doing a side effect by changing that state. So that's why this doesn't count as a pure function. Does that make sense? Okay, cool. And then, yeah, here, sorry, I'm just gonna reload this slide maybe. Is it on? Or I just like add, I think I missed something earlier, but it's here. Okay, I'll just click present again. Okay, there we go. Okay, so this is an example. I meant to delete these things and then have them come up on one by one, but I forgot to do that. So it's technically a multiple choice question, but the question here is which of these is not a pure function? And I mean, you can see the answers are there, but there's a lot of words, so I'll just talk about it. But this first one is the only one that's not a pure function. And the reason for that is because it's not returning the same value every time, right? Because this is a block that says pick random from something to something. So say we have pick random from 1 to 5, even if you always have 1 to 5 as the inputs, every time you click it, it's not going to return the same thing. So it's not a pure function. The rest of these are all like either mathematical functions, like this less than or greater than. It's always going to be the same. If you always have a value in the left that's greater than the one on the right, it's always going to be showing you, it's always going to give you true. So regardless of what the inputs are, if they're the same every time, it's always going to give you the same result. So these are all always going to be the same. And then true, this block is also a function. It kind of looks like it's not a function because it's not actually doing anything, because this is just true and it's always going to be true. But remember that functions can take in 0 or more inputs. So even though there's no input here, it's still a function because it always gives us the same thing. Does that make sense? Okay. Cool. Yeah, so this is just a review of like what the definition is. So again, a pure function is a special type of procedure with these properties, 0 or more inputs. It gives us some output and it always reports the same output for a given input, and it doesn't have side effects. So now we're just going to talk about really quickly why the last two things are really important. So why is it really important that we always report the same output with a given input, and why it's really important that we don't have side effects? So a pure function always reports the same value given for a given input. And so our count by block that we just talked about, that's not a function because its behavior depends on the pass, right? And does anyone have any ideas why it's important for keeping the same output consistent with the same inputs? Can you think of any issues that might arise if we don't do that? Okay, well, this would actually cause, so this isn't like an example, but this is just overall the reason is because we no longer have an opaque abstraction barrier. And what that basically means is that we can't really, if we can't count on this fact, then we actually have to know something about how the block works and how it's doing what it's doing in order for us to use it. And that breaks our abstraction barrier, right? Because if we remember, as the user, we don't want to need to know how things are working under the hood, basically. We don't want to need to know how the block is working. We just want to be able to use it. And in order to assume that it works correctly, we have to know something about like the secret number, something inside of our block. In this case, like the secret number that's being stored in our count by block. We can't depend on it because we don't know when the last time that it was called. So we don't know what that number is. We won't know what to expect for the output. So that's why this kind of breaks our abstraction barrier. And yeah, so again, we have this quote here, our enemy is complexity. We want to do everything that's possible to avoid it, which is what we were talking about with abstraction yesterday. We always want to avoid making things overcomplicated. And if we have to know some extra information outside of just what's given to us in our block, then it's going to make things more complicated. So that's why we want to keep our abstraction barrier completely opaque. We don't want to need to know what's going on under the hood. Does that make sense? Okay. And then really quickly, so why is avoiding side effects important? And I think this is kind of maybe more unclear, but yeah, so remember a pure function in CS10, it's not going to have any side effects. So imagine we're writing this code for Super Mario Brothers game. It's okay if you're not super familiar with it. I'm also not super familiar with it, but basically when Mario gets an item, he changes states. And if you remember, we talked about pure functions should not be changing state, right? And that doesn't mean, again, that the game can't change state. The game will have to change state at some point, but we just don't want our pure functions to be changing that. So as an example, mushrooms make Mario bigger, fire flowers make him able to shoot fire, leaves make him able to fly. And these are some like things that are changing the state of Mario. It's changing the state of how he's moving and how he looks. And so when Mario hits an enemy in the game, then he loses this item, right? So that's kind of our setup for our Mario game. Is that clear so far? And then say we're trying to write some code for this game, right? So our question here is, will this code work properly if Mario gets hit? So we want to assume that this block over here, so we have these two blocks. We have process enemy hitting Mario. And we're told that when Mario gets hit, if we go back to this slide, when Mario gets hit, he has to lose his item, right? So we have this code here. We say, is Mario is big? So we check if Mario is big. If he is big, then we play a sound, and then otherwise we lose if Mario's not big, right? Because if he hits an enemy and he's not big, then he's just gonna lose right away. And if he is big, he's just gonna lose whatever item he has. But if we look inside of this is Mario big block, we have another, let me move this. We have another if else block, right? And here we have if has mushroom or has fire flower or has leaf, then we want to take away Mario's item. And then we want to report true. Otherwise, we want to report false if he doesn't have any of these things. Does that make sense what we're trying to do here? So does anyone see like any issues with this? Any ideas? Yeah.
Just playing the sound there.
Yeah, so yeah, that's a good point because we need to make Mario small again to take away his item, right? Yeah, that's basically the idea. So right here, all we're doing is playing the sound. So it kind of looks like, okay, like it's not actually changing him, right? But if you look inside of the is Mario big, we see that in here, we have this take away Mario's item block. So it will actually take away the item. So this code will work correctly, but it actually isn't the way you want to actually code in practice because our is Mario big is like a reporter block, and we usually want our reporter blocks to be pure functions. And Maddie will talk about that in a second when we talk about like our different block types, but usually our command blocks are the ones that are doing side effects, and our reporter blocks shouldn't be doing side effects. They should be more pure functions. And here, so if this was just a pure function, we would actually just need to remove this orange block, take away Mario's item, and we would just want to put that in this if statement instead. If is Mario big, then we want to take away his item and then play the sound. But instead, what we're doing here, if Mario is big, this block itself is taking away the item. And this will work in this case, but if we have another situation in which we need to check if Mario is big, for example, here, yeah, so the code might work in this case, but having this block both check if Mario is big as well as taking away his item and making him small again, that's not always a good idea because it's doing a side effect. And if we need to check that Mario is big in a different situation where maybe we don't actually want to take away his item, then that's going to cause us a problem. Like, for example, if you've seen in Mario, when he hits like bricks, he like jumps up and like hits some bricks, then the bricks are going to break if he's big. And if he's not big, then the bricks aren't going to break. And we need a different way to check if Mario is big in order for that to work, because if we just do it in this way and we just use the same is Mario big block, every time that it hits a brick, it's going to take away his item and then he's not going to be big anymore. But we don't want that. So a better way to do this is to just have this take away Mario's item block separately and just put it in this block of processing hitting Mario separately. And just in is Mario big, all we want to do is check if he has a mushroom, if he has a fire flower, or if he has a leaf. Does that make sense? Okay. Hopefully that was clear. If there's no questions, Maddie, I think, is going to take over with block types.
All right. We feeling good so far? Okay. Yeah, let's talk about block types in Snap. So hopefully you went to lab today and you did, you were building some of your own blocks, which is very fun. You will have seen the screen. And when we build blocks, so by the way, let me just be clear here. A block is anything in Snap that I can grab and drop inside of the stage. Good on that? Okay, excellent. So basically what programming is all about is building your own blocks, building your own functions. We use a couple different words for that. But in Snap in particular, and there are more reasons for this that I will go into, we have three options when we build. We can either build a command, we can build a reporter, or we can build a predicate. And it's important to choose the right one when we're building our own blocks. So we're going to go through what each of these does. So a command looks like this. Okay. It snaps together, snap, get it, with other blocks. And you'll notice that it is the only kind of these three that can do that with other ones. So maybe you were in lab and you got kind of angry because you were like, well, I need to take the length of this, and then I need to do this right after this, and it won't snap together. And there's a reason for that. So command blocks are the only ones to do this because they do something. They are a command of some type and they make something happen. They do not have outputs. They're specifically meant for side effects. What does that mean? Are commands going to be pure functions ever? from what we just learned from Diksha? No, because pure functions should not have side effects, right? So these guys are never going to be a pure function. And that was on the slide, so, you know. Moving forward, reporters look like this. They're round on the sides. And these guys are used to implement functions, usually pure functions. They might take inputs of their own. So you might notice that this plus guy right here has 2 blanks. And what might I do with those blanks? Put numbers in them. And when I put numbers in them, what's going to happen? Don't make me talk to myself, guys. We're going to add them. Yeah. So it's a reporter. Reporters can take in information and then do stuff with it. And their job is to report stuff. So the output is going to get reported to whatever we put our little reporter guy in. So the reason that they don't snap together is because we need to put values in places. And what reporters do is give us values to put inside of our commands. So they give us a way to kind of have that information travel around our program. Okay. Amazing. And then finally, we have predicates. And what's really important here right now is that you understand the distinction between commands and reporters. And once you do, you're good with predicates because predicates are just a special type of reporter. They look like this. They got the little arrows on the ends. If I ever sub for discussion, because I used to teach a lot of discussion, you'll see me draw a crappy one like this. Okay, so they have the little corners on the sides, and we'll go over what those do in a sec. But they're just reporters. Okay, questions about any of this? We will post slides as usual. I don't know if we posted yesterday's, but that'll happen at some point on the website. Questions about these three? If I asked you some questions, you'd know exactly which one to pick when you're building a block. Yeah, totally. Totally, Maddie. Okay, cool. Great. So the difference between commands and reporters, talk about that a little bit more. Again, command blocks do not report anything, but they could say something, which is a little bit different than reporting something. There's something akin to this in Python. So this is definitely a pattern that's going to come up. But essentially, saying is not the same as reporting. Saying is a side effect because it appears on the screen. But reporting is when we actually give a value to whatever command block we're inside of. Or if it's a command block, we can also put reporters inside of other reporters, which we'll get to in a second. Yeah, and you'll notice same thing goes. We can't put command blocks inside of other command blocks. Or you can't put them inside of anything. That just can't be done. And then reporters. What's cool about reporters is we can start doing some really interesting stuff. If you've done math and you put like functions inside of functions inside of functions, or if you've done like PEMDAS in elementary school or middle school, you remember like having to like follow like, oh, in the parentheses, and then I do this, and exponents, and then multiplication. We can do that, except it's much more clear. I work from the inside out, which is always something to remember. Okay. Questions about this? No. Okay. Again, kind of making this distinction here, say is not the same as report. Say is a side effect. It is a command block. It is not a reporter. It is not reporting anything. Questions about that? Okay, amazing. By the way, if you ever have a question like, what if I did this like one thing? How can you find that out without ever even asking anyone? Which you should always ask someone if you have a question, but how might you find it out sooner? What? I heard something. You can open Snap yourself and do it, right? That's how you learn anything in programming is you gotta learn it. You might break stuff, that's fine. But test all this stuff out for yourself. Maybe I'm lying to you. Have you ever thought about that? I'm not lying to you. This is composing reporters. Again, what I just talked about is you can do like really awful things like nest things like that to do some complicated math. Yeah. So just to say that reporters can go inside of other reporters, can go in other reporters, et cetera, et cetera, et cetera. What's going to happen here? And just, this is a custom block. You probably noticed there's not a cube block, but let's pretend I built a cube block, which cube things. And if you don't know what cube means, it's exponent to the third. What's gonna happen here? What am I gonna get? Also, what type of block is this? This is a command block? No, it's a recorder. What's gonna happen? I get what?
Eight.
Did I get 8? We're gonna cube 2. What's 2 cubed? So if we're cubing 2, it's 2 times 2 times 2, which is 8. And then we gotta, then this inner guy is gonna report to this outer guy. So now we want to cube 8. What's 8 cubed? Easy, 512. I had to use a calculator. So well done to you. You can look at this later. Okay, data types, domain, and range. Okay, so we'll talk about this more in a sec, is that a lot of programming is just doing stuff with data, and there's a lot of different types of data. So there's stuff like numbers, then if you go into math, there's stuff like natural numbers and rational numbers and things like that. There are letters, there's text, there's words like ketchup, fish, and leg. I didn't choose those. There's sentences, and there are booleans, which I will also talk about in a sec. Point being, there are different types of data, and sometimes some types of data don't work with other types of data, and we have to pay attention to that. This you're going to learn in lab, but essentially when you define a function, or when you build your own block, you can specify what kind of data you want going in your block so that you don't get bad things happening, which we'll talk about in a second. Okay. I hope you're ready, because I have some pretty amazing animation skills. So yeah. Basically, I got a function right here, a little f of x guy. Maybe you've seen something like it in math. What's cool is like I could put like any kind of like little function in there. And what I like to do with this box is like put things in it and get things out of it. Okay, it's kind of how a function works. Diksha talked about it. So I put things in there and get things out, right? What if I just like put anything in the box, like anything I wanted? And what if I don't know, like my function was the square root? What happens if my input is like -4? What's the square root of -4? Does anybody remember? I hear whispering. You can say it to me. Say it to my face. Yeah, you get 2i, but when I do that on a graph, unless I'm looking at an imaginary one, you can't do it. Because we don't want to go into imaginary stuff, and we don't really have any practical use for that in computer science. I appreciate that answer though. Yeah, you can't do that. Error. And so we kind of have to say like, well, you can't just put anything in this box, dude. You gotta tell me what I can put in that box. And so I have to define what goes in the box and what should come out of the box. Okay. So we have these ideas of domain and range, and hopefully you've heard of these before, right? So like, you've heard that maybe like my domain is like only real numbers, my range is all real numbers. Maybe sometimes it's only positive numbers like square root. So same thing goes for blocks. Okay. So, and remember, each block is like a function. It does something, if it's a reporter, we put something in and we get something out. Okay. So for square roots, that means non-negative numbers for domain. We don't want to put negative numbers in there unless we want to be doing imaginary math. And I should have told you before, I did not want to be doing imaginary math, because in some ways that was a valid answer, and I'm kicking myself for not thinking about that. But the range of that is going to be non-negative numbers, right? When I take the square root, I'm going to get non-negative numbers. Same thing for length. You've seen that little guy before. He takes the length of text. He will not take the length of a list, which we'll talk about, or actually, forget I said that because that was a bad example. But the range of length of will be a non-negative integer. I can't have a length of -3, at least in this space. I have less than. I'm going to put either text or a number in there, but usually just a number. And then I'm going to get out a Boolean, which is a true or false value, which I will talk about in a sec. I can have ands and ors. Somebody did not do some good copying and pasting. It was me. Yeah. So again, we talked about this, that you can modify things so that, and it's important to note here that like, when we're talking about what can go in and what can come out of a block, that this shape will kind of change to reflect that. So that should give you some kind of hint before you go coding things about what a block is going to take in terms of domain. Okay. How are you feeling about all of that? Block types. Do we like my animation skills? You can tell me no, it's okay. Thank you. Okay. Predicates and conditionals. So a predicate is that guy. And he's just a special type of reporter. And he will give you a true or a false answer. So kind of maybe an important distinction here is he's called a predicate. And he will report something because he's a special type of reporter, but this is his name, by the way. And he will give me an answer that is called a Boolean. The hell is a Boolean, Maddie? I'm going to tell you. A Boolean is a true or false value. It's not a number. It's not text. It is yes or no, true or false. It's binary, meaning it has only 2 possible answers. So examples of this, anything that evaluates a true or false is going to be a Boolean. Checking my time here. Cool. So, you know, in that Mario game, has this person won the game? Maybe I'm putting up Mario. That's a yes or no answer. There's no maybe, right? Especially when we get into computing and things like that, you don't really have room as much for maybes. It's a yes or no question. So, and we'll get into this more as we get into binary and hexadecimal and things like that. There's a lot of Booleans in computer science, and they get really important as we learn more, especially as you get into 61A, B, and C. Another one is, did you drink enough water? It's yes or no, true or false. Hopefully not maybe. Yeah, these become a lot more important. There's also some really cool stuff we can do called Boolean logic with it. Go to discussion today to learn about that. That's really important. It is in scope for every aspect of this class. It will be just as important as everything else on these slides and exams and labs and things. So go to lecture or go to discussion. Freudian slip. Okay. And then conditionals. So conditionals take Booleans. How do I know that? How do I know that? Yeah. So conditionals take Booleans, and then based off of the value of the Boolean, which will be true or false, yes or no, it will do something. So if 5 is less than 10, it will say, surely it is so. Wow, I didn't put that. That's nice. But yeah, you will do more of that in lab 3 tomorrow, which is very exciting. And I have a little bit of time to talk about variables. So programming as a whole has everything to do with data and doing stuff with data. We need some way to kind of generalize. We need some way to kind of have some kind of working memory. And I'm not talking about in the computer science sense, but some kind of memory of what the hell is going on. So we use variables. Okay, so this helps us to generalize. This is something we do all the time. If I tell you I have to take a quick quiz and then it'll take me 2 hours, you know that if I start at X time, I'll be finished at X plus 2. Good old like little equation formula thing, right? And again, like variables maybe aren't new to you, right? Hopefully you've seen them in math. But from there, I can give you any start time and you'll know my end time. Therefore, my start time is a variable. It can be anything, but you can still work with it because to you, it's start time and it has a meaning to it. This is what allows us to write reusable code. So let me think. Everybody do their field of flowers in lab. Yes, that was a fun one. You can tell it how many petals to have, right? Does everybody remember that? So that's a variable, right? We use that inside to, we didn't actually use it as a variable as we will be going forward in the future, but I said how many petals I want. And so I make this assumption inside of my code about how many petals, and whatever number I'm given, I am using. So I need to have some notion of like holding on to a piece of information I've gotten and using it in a specific way. But I might need to refer to it even though I don't really know what it is. It's something, but I need to refer to it when I do my calculations, just like you needed to refer to my start time as something. So, you know, we use X, right? So that you can make that X plus 2 calculation. And then later when I give you that number, so I don't have to give it to you now, but you know right now that my end time is X plus 2. And so all you have to do is once you get my start time, you just plug it into X, right? Again, probably familiar, okay? That is about it for today. Oh, okay. So yeah, the self-check is going to come out. Oh, okay. Sorry. Right. So just so you know, the first self-check is due tonight. You should be able to get full points on it because you can submit as many times as you want before the deadline. And it should tell you your score now. There's no reason you should not get full points on that. Easy points, right? And also, yeah, it'll be the same on this one. And then what you can do actually now that we have it configured the right way is that you can press save answer and it'll tell you if you got it right or wrong. And then you can go back and attempt it before even submitting. So you won't have to resubmit every time. Another thing is if you're going to discussion right now, Silas is not able to make his discussion. So I'm asking everybody to go to Vedansh's. And I believe Vedansh's is in 320, but we're going to squish everyone together. What? Okay. Any questions? That's about it. You're always welcome to come up in the next 10 minutes or so. It's down the hallway, yeah.